Oh, class.
I was over your way, neck of the woods. The other day, Professor Sylvester passed through there going up. I had to go up to Grambling to pick my nephew up.
Well, you passed to Port Barry?
Yeah.
Hey, did you slow down?
Yeah, I slowed down coming through there.
Yeah, you better. They don't play around, man.
I know.
Yeah, I tell you. Yeah, they something else. Man. Yeah. So what, you went to Grambling?
Yeah, he go up there to Grambling. I had to go pick him up.
Oh, okay. All right. Oh, they spring break.
Pretty much. Yeah, okay. Yep, they spring break. They had, but I think they up that way they on spring break, but they can come on home and finish out the semester.
Okay, they got that option. Yeah, once. Okay, yeah. All right, that's all right though. Yeah, buddy. That's a good little ride though, man.
Oh yeah, it is.
Yeah, man, because Shreveport is like 4 hours from where we at, but it's a little less now because of I-49. But from Baton Rouge, it's a good little ways. Man.
Mm-hmm.
Yeah, almost like going to Houston.
Pretty much.
Yeah, I tell you, man. Yeah. Man. But it's a good road though.
Oh yeah, since you got 49 and then the other parts they look like they repaved and stuff, so it's pretty good.
Oh yeah. Yeah, but did my program?
No, I started. I was looking at the
grade. Let me ask you something. Why you don't do my header file?
I do. That's what I looked at when I saw my the points taken off. I do the header file. I'm telling you, I did, Professor. I did the header file, but and I went back and I made sure it was in there when I reran it.
No, listen, but you got to submit your header file with your program.
Oh, okay. That's where I messed up at. I thought when I submit the program with the header file, okay.
No, but it's like you put the command or the to load the header file, which is the file you created, but you got to send me the file you created also.
Okay. That's all right. That's what
right. Because what I normally do, I just use the header file that I have, unless you do some other stuff in it, because I'll get an error or something. But normally, what I'll do, I'll have a header file written. But if you got your function call in it, it'll pull up my header file, whatever. So, but I'll just take off 2 or 3 points. Okay. But if you don't have the header file at all, and don't have the function call or whatever in it, then I'll just take 5 points. I told y'all that at the beginning of the semester.
But I thought that's my fault. I just thought when I did it and I put it into the program, that was it. From now on, I send the file to you. That was my mistake.
Yeah, you gotta send them both, man.
Okay.
Yeah. Oh yeah. Anybody else got any questions or whatever? Because the semester steady rolling. Next week is spring break. So, and so we won't have class next week. And
Professor, did you ever get the email that I sent you?
When that was?
Saturday.
Saturday. Did I get them in there? I normally respond by then. Let me see. Again. Let me see. What's your first name? What's your first name?
Hallie,
Hall.
IE.
Let's see what it's showing. Hold up. I responded to one of them. The last one. No, whoa, no. The last email I got from you is, yeah, see, Saturday at 209. I didn't respond to that one. And then one before that. That one before that did I respond? No, that's in January. Yeah, you did two of them to me. You gave me two of them and one today. No, 3-2. That was the back one. Okay, let's see what I got in there. All right. Now, didn't I talk to y'all about this in class, or not in class, before? Didn't I send an email about what I'm making sure that your program run in Visual Studio? You know, you can use the other applications. I don't have any problems, but you got to make sure that it actually runs in Visual. And I think you, and it was a couple other people, you used the string, like string name or string, whatever the variable name was, but you didn't load the header file upon include string. And what would happen is that program, like I say, you're saying, oh, it works, whatever. But if you were to take that program and put it on in another compiler, it would not work because the string header file is not loaded. Remember I said at the beginning, even online GDB, it's a watered down version of C++, meaning that certain things can be done without getting errors. Like one particular thing I know in Visual Studio, in online GDB, that's different in Visual Studio. In online GDB, I could create a variable and don't have to give it a starting value, a 0 or anything. And then I can go in and use that variable and say, I could say int x, and I could say x is equal to x plus 5. So now x plus 5 in Visual Studio, it'll say, okay, x plus 5, but I don't know what x is, so you're gonna get error. In online GDB, it says, okay, x plus 5. Oh, x is declared as integer. Okay, no value was given. I'm gonna assign it 0. You understand? So those type things. But when you run it on a more sophisticated compiler, you would get those errors, right? Now, Mr. What is his name? What is his name in your class? Let me look on this. Mr.
I think that's me, right?
Yeah, Mr. What?
Me.
Yeah,
yes.
you called me, right? Well, you Zoomed me, right?
Yes, sir.
And he talked about it. And what I told him was, I reached out to y'all before about this. What I might go back and look at it, and I might give y'all some points for at least turning it in or whatever. But don't bank on it. But I'll toward the end of the I'll consider it. Say, okay, well, they did whatever. Right?
Yes, sir.
Everybody understand. So like I say, maybe toward the end of the semester, I could look and say, okay, well, let's see. What they grade, they 1 point from without they 2 points. Let me see if I put in the grade for them, like say give them half credit. Will it boost it up? Well, okay, well, I may give you credit for it. Yes, right, Miss Haley, what her name, last name? Is it Callaghan?
Yeah.
Callaghan. Okay. Right. But like I say, make sure that you follow, because when we go over it, like I say, use that string library. Load your string library. Now, I think someone had asked me at one time, well, Mr. Sylvester, can I just load all the header files and then do the pro? Yes, you can. You know what I'm saying? You can do that, but what happens is, like I said, just make your program larger, but it can be done. You know, you just load all the header files that you think you're gonna need, and then from that, you you know everything is straight. Right.
Yeah, you also said that my program had another error that
Oh,
that I didn't put streaming. The streaming I forgot the name of, but it was
oh, you
you
want me to
said I
put?
got an error for it, but I don't have an error for it because it's in my program. It's coded
Yeah.
in my program. I don't know why it didn't run for you.
All right, you want me to? Can I pull it up?
Yeah.
Okay, so let me go here. Let me go to. Okay, here. That's you know which program it was? 1, 2, 3.
Yeah, I think it was chapter 3 program 2.
Okay, all right. Let's see. Let's see. And let me share my screen. If I can, okay, let's see. I cut my thing on when I didn't know. Okay, share my screen. Where's that option? Okay. All right, let's see. Great. Okay. Let's see, program 3, chapter 3. Yeah, and I still got a grade others. No, no, wait a minute. It must be 2, huh? What's your name? Caligan. It must be 2 because that's what a 0 is. Okay. Let's see. So, I need to move this other way. Speed grade. Oh, let's just upon include and no using namespace STD. So,
Yeah, that's what I'm talking about. That I did put that in my code. I don't know why you got an error for it though.
but look, this is what you submitted. Look. Now, let me tell you, you got it. Let's see, I'm gonna see. Yeah, you have it here, right? But
Mm.
this is only for this. But then in the actual CPP program, see if it comes up. Okay, we go. Right, it's not in here. You see
But
what I'm
I
saying?
thought if you already called it in your header, you don't have to call it
No, no,
again.
no, no, no. It's like say, see if I do IO man IP in the header, yeah, I don't have to call it. But the standard library, that's different. You know, because that won't let me pull up your program. Let me show you. Because the standard library is for that program. You know, you need to have it in there. So did I pull it up? Okay, it's up, it's up. Okay. This is your and what I see, I just create a header file like this. And what I'm gonna do, I'm gonna copy this and paste this here. All right. So, oh yeah, well it did work. It did because see, I would get an error on the C out. No, yeah, I'll get error on the C out. But watch this. Find include. All right. And that takes that off, and it should work. So the other one, yeah, the other one really not an error because it's gonna read. It'll read it from the other one. Yeah. So here, and that's my header file, and then this is the program. All right. But you got to be able to have that string library in there in order to when you got string name, yeah, you need that string library. Yeah. So that was good, but yeah, you got it. Using namespace. Good. Yeah, that's okay. That one was okay. But the this caused the error, the first really the error that for this. Yeah. And a lot of times I look at the program like, well, the code is right, the syntax is right. And then I gotta keep looking, and like, oh, the header file. Sometimes it be the header file. Yeah, the code be perfect, but it's just that the header file is not there. And like I say, some compilers they may work different. It's just that remember, if you're gonna use string, use the string header file. If you're using the set W, the set precision, the fixed, you gotta use the IO man IP. You just gotta know those header files. All right. Yeah, but that other one, that shouldn't be. Yeah, but I would say, yeah. But if you would take this off, then you would have to. Well, you'd have to have both of them anyway, the IO string and the user namespace. If you took that off, so you got it in the other one. Yeah, but that's why. Like I say, I do make mistakes at times, but I don't try to just take.
It's okay.
Yeah, I don't try to take points, but like I say, I'll run it, soon. But like I say, I might toward the end, I might look at it at those zeros and say, okay, what was the problem? Okay, error, and I say, oh, no string header file. Okay, and then you ran it on the Mac. Let's see what happens. Yeah, because that'll help your grade normally considerably. If you get even half credit, zero is just a zero. It just drop your grade down. But hopefully, we'll do more programs that are gonna help you boost your grade up. And like I say, you pass your test, should be all right. Yeah. But getting that zero gonna keep it on your mind, like, hey, I know I have to do this, right, Mr. Booker? Is it there, Mr. Booker? Oh, he on mute. Okay.
I'm sorry. Yeah, you're right.
Okay.
I know next time.
All right. Any other questions, class? Anybody with a question? All right. Because like I say, this program, let's say, okay, you ran in the name, the actual job title, wages and hours. Okay, so you did the CLCN for each one. Now, so I think I may have made maybe one or two people, they use CN to get the name. And what we said about the CN, with the CN, you got to watch, because if a person put a name without any spaces, no problem. But if they put the first and last name, or name like a name with a space in it, then all of a sudden you can't put in the next value, because it's going to take that information out the buffer and put it for the job type. So I had a couple of people do that. For the most part, everybody got their wages and information correct, so that was good, Everybody did the percentage right. They got the taxes added to the gross. That was correct. Some students, not all, didn't do how would I say it? Some students didn't even follow the format at all. What they did was name, next line, name and the name, next line, job title, whatever the job title, next line. So rather than go across like I had the information, they had the information going down. So I'm like, no, that's not how I wanted it. Some people did it going across. I think one person had the name with the column width, but then the job title and everything else didn't have the right column width. Some people, what they did, they wrote out the information with having everything to the left, and not go and put the name. I mean the information for the wages and whatever to the right. Okay, so that was an issue. All right, so some those little things like that. Some people didn't use the decimal place. Some people didn't put the one decimal place for the hours work, stuff like that. I took off 1 or 2 points sometimes for no decimal place. But if you just didn't do any of them with decimals, then I took off more points. All right, because you didn't even try to do the our man IP and whatnot. All right. But like I said, I still have to finish grading the other assignments. So any questions? Anybody with any questions? Any questions? All right. Okay. So let's get to the chapter. All right. So we looked at when we was doing grades where I'm telling you A, B, C, or D. And what happens is with these ifs, you can use if, else, if. You know, if this, else, if. And using the else if allows you to control, okay, I want to go into this next body of text rather than do if this, then if this, if this. So you're doing an if for each one rather than an else if, and without the else, it's gonna test each time. Like for this code, if I say if test score is greater than, well, am I sharing my screen? Yeah. If I have if test score greater than equal to A score, it's gonna check to see if it's greater than equal to 90. But if I don't have an else here, then it's going to do if test score greater than equal to B score, which would be true. And then it's going to print out this. And without this else, it'll do the if for this. And that will be true. So I would get grade as A, grade as B, grade as C, grade as D. So I would get all those answers or responses, and that would be wrong. But with the else, it's checking to this and say, if this is not true, then else do check to see if this. If that's not true and that's not true, else check to see if it's this. So you're like eliminating rather than like including, like before. And I'll show you the case statement that can do the same, basically the same thing. And this says using the trailing else to catch the error. And that's like somewhat like this. You know, this is like a trailing else, because what happens if you don't have an A, B, C, or D, else it's an L, so it does that. But they went on further to try to see if the grade was below a 0. So if the grade was below a 0, so if it's greater than 90, greater than 80, greater than 70, greater than 60, greater than 0, it's an F. But anything below a 0, we know that the score pretty much is invalid because nobody really make a negative score. Because even if you get caught cheating, it's not a negative score, it's just a 0, right? It's just a 0. They can't take more points than the test is worth. But if it's negative, then that's why this else come in and says, okay, that score you inputted or whatever is not correct. Okay. So nested ifs. Okay. So that's basically what that is. You have an if statement within an if. All right. So if, else, if, all right, compared to nested ifs. Because I can do if funny, do this, else if, well, if this, which would be nested, but you let's see. No, that's not it here. It says you never have to use the if else if statement, because its logic can be coded with nested if else statements. However, the long series of nested if else statements has two particular disadvantages, right? The code can grow to be complex and hard to understand, or the indentions be so far, and whatever, so deep, it can get confusing, all right? So it's important, because indention is important in nested statements. A long series of nested if-else statements can become too long to display on the computer screen without horizontal scrolling. And like I said, it becomes so deep, you start having to put code based on getting out of that loop, you can run into a whole lot of issues, all right? You can run into a whole lot of problems. But many times you may have to have nested loops so that you can accomplish your task. You're gonna ask one question only to ask another question, all right? Now, we kind of talked about flags. A flag is a Boolean or the integer variable that signals when a condition exists, right? And remember, I think what I did, I showed you how you could say if quota or if not quota. So here, look, if sales quota met, all right? Sales quota met here is a variable, all right? If that variable is 1, then it would be met quota. All right, well, it would perform this. If it's 0, it would not. All right, and I gave you an example of how to do that, of how that looks. All right, so if I said something like this, and we had something even like this, and I said down here, where wages, and if I do this, if not wages, right? Say I can do something like, well, I'll just say if wages. That means it's true. So if it's 1, if I say if not wages, it would do if it was 4. So I'll say if wages, not that, then I want to perform this. Because what? If I don't have a wage to perform, why perform? Well, give you 0, whatever. But let's take this, okay? If wages, we're going to perform this, all right? So now, so that means if wages is anything other than 0, we're going to do this. If it's 0, we're going to just get whatever. So I could do else. I could do something like else. I'll say gross pay equals 0, tax equals 0. And why is that? Why am I getting this? Okay, GROSS. Let's say string. If wages. Why am I getting this error? That's gross pay. Gross pay number 5. GROSS. Oh. See, now, I don't think we went over this, class. The scope of this is only within here, all right? And what I mean by that is it was initialized, or it was declared with, or initialized with a expression within here. What I would have to do is say, okay, take this out of here, and I want to make it the scope of the entire main function. So I would do this, gross pay. Yeah, okay, pay. So now gross pay is here. So now it took that off. But what I need to do is I need to take this off and put this here. And I need to do taxes and net pay. So now I do tax and net pay. And that was all because of the scope, all right? When I declared a variable inside of this if, just like when we did functions, remember we did a function and we had a variable declared inside the main? The variable was only known inside the main, not in the function. Same thing here. The variable is only known inside of that scope where it was defined. So what I did, all I did was made gross pay, tax, and net pay known to the whole main function, all right, because I declared it here. I could have made it global out here, and then it'd be known to any function and anywhere in that program. So let's run this. So, and I have, back to what we was talking about, we have if wages. So let's debug this, all right? And what we'll do the one based on the example in the book. So let's say put John Doe, and then we'll put manager or something, and then we'll put 10, which will end at 80. Now, See here, this is correct. Well, no. See, this I think should be right aligned. Remember, based if I'm recalling right. Right align, right align, right align. That's right align. See, that's not right align, right align. So I think this was left, this was left, this was left, this was left, and all of this was right align. All right, but if you see, what happened is it printed the 80 time, whatever, and all this. But watch this. If I run this program again, and I'll put John Doe, manager, okay, and then I'll say, that's spelled wrong anyway. I'll put 0 and well, it a 0 all the way. But what happens is I put a 0 here. So this says if wages. This is gonna check to see if wages is anything negative or positive other than 0. If it's anything other than 0, it would perform this. But if it's not, it'll just give me this information, then continue. So it should have what? See, all zeros going across. Because what? We know wages was 0 because it was inputted. We know hours was 0 because we inputted it. But it didn't calculate gross pay. It skipped this and it said, okay, else gross pay is 0. And then taxes equals 0 and net pay is 0. All right. So see, that's how that works. Okay. So this, and if I put a not here, then it'll go check to see if it's not wages. All right. And if it's not wages, meaning it's 0. If it is 0, it's going to do this. All right. Going to do the reverse. Now, so you can compare in that fashion. So let's look at our N and our R. We kind of looked at this, right? I think we looked at this. I'm not too sure, but we'll go over to kind of get a better understanding. Because I think somebody asked, well, Mr. Professor, can we mix the N and R together? And you can. So if you look at this, these are operators that are logical operators, all right? You got and, okay, that's what its meaning is, but it's the ampersand, ampersand. And you got or, which is the 2 pipe symbols at the top, above the enter key or the return key on your keyboard. Shift and you press it twice. And then you got not just reverse the logic of what that expression is, all right? So, and includes, all right, meaning that both sides have to be true. Now you say, okay, Mr. Sylvester, what you mean by both sides? What happens is you have an expression or something to evaluate here, and you have something to evaluate here. Now, we know in math, we can say X less than Y less than Z. You can't do that here. You have to always have, like, look at this, temperature less than 20 and temperature greater than 12, all right? Right? So you got to be able to compare it to something, all right? On both sides of the logical operators, right? Otherwise, you're gonna get an error. So let's look at our program. So we have this, we can say something like, if we say if wage is greater than say 5, okay, and we say hours like that, that's an error. Because what? I got this compared to this, but I don't have this compared to anything, right? I have to say hours not equal, hours greater than, hours less than, hours greater than or equal to, hours less than or equal to, hours not equal to, something. I can't just put hours on that side. So I'll say something like, and we just kind of changing up the program. So if the wages input, put it is greater than 5, and I could say and hours, okay, I'll say less than or equal to 20, right? So if I put in like wages is 10 and hours is 20, it will fall into this. If I put wages as 3 and this is 20, it will not. Now you say, well, why, Mr. Vessel, why won't it do that? Because remember when we looked at our and or logic, let me go here and see, can I pull it up? If I click here and go here and go to 193 and we go to and on here and the truth table. All right. So when we look at this truth table, what it's telling us is, remember I said one side comparison, this would be hours and wages greater than 5. That's the P side, it's checking that. The Q side would be hours less than or equal to 20, right? So you got this and this, okay? So P and Q. So if P is true, which means, let me pull this back up. And I'll let this so small you can't really see. All right. So I'm saying if I can get this out the way, man. Okay. If P is Q, true, which means wages greater than 5, okay, and Q is true, hours less than or equal to 20, then perform this, because it's going to yield to be a true condition. Everybody understand that? I got to have something to compare against this for the P side, something to compare against this to be the Q side. Compare this side, what it equates to be true, equates this true, it will do this true logic. But if any one of them is false, if this is true and this is false, then it's going to do false. It's going to yield false and do the false condition. If this is false and this is true, it will yield to do the false condition. If both of them is false, obviously it's going to do the false condition. So looking at this, okay, when it says wages greater than 5, okay, depending on what we put in, what it yields, and hours less than or equal to 20, if both sides is true, then it will do that. If this is true and this is false, it will do this. If this is false and this is true, it still goes down and do this. If this is false and this is false, it still go down and does this. All right? Okay, so let's run it. Let's see. Let's say greater than 5 and less than or equal to 20. So let's debug it. Okay. So an employee, I'll say John Doe. John Doe, okay. In a job title, I'll say manager, all right. Okay, in a employee wages, I'll say 10. 10 is greater than, well, that's 20. 20. 10 is greater than 5, so we're making that true, okay? So 10 is greater than 5, right? Then it says in a hours work, okay? We want to make it true. Anything less 20 or less. So let's make this 18. So 18 is less than 20. So this side is true and this side is true. So it should give us our values. Okay, see? It gave the values. Okay, 10, 18, multiply that times that, got 180. What is, I forgot, point whatever percentage of that, gives you that, subtract it from that, and that should net pay. Now, let's do it again. Let's run it. Let's see the bug. So now what we'll do, let's say, make that, say John Doe. And let's say make this true, say 7, but let's make this false. Let's say 50. Now, 7 is greater than 5, but now we got and, but is 50 less than 20. That makes this false. So what? True and false yields false. So it's gonna give you, it's gonna multiply, or it's gonna assign these values to 0 and then output the columns in the row. So hit enter. Whoa. Oh yeah, because see what? This is greater, which is 7. 7 is greater than 5. But 50 is not greater than, less than or equal to 20. So it gave me what I put in for the hours and whatever, but it yielded to be false, and what? It assigns zeros to this, all right? Everybody understand that? This side true and this side true will perform this. But if either side is false or both is false, it will do the false condition. Now, that's and. But if I come here and change this to no. If I change this to R, all right, see those two symbols? I'm in that symbol, all right? It's a straight line, all right? That's the pipe, that's what is the pipe symbol, but we use it here as an R, two of them together, it's R. So what this says, if wages is greater than 5 or hours less than equal to 20. So what this means is both of them don't have to be true, but if they are, good, I'll do the true condition. If one is true and the other is false, it's going to do the true condition. If one is false and the other is true, it's going to do the true condition. But if both of them are false, then it will do the false condition. So everybody remember what happened when we did the and. Both have to be true. So let's run it this time. All right. This time, we're going to put in 7 and 50. I think it was 50 we used again. So we put John Doe and manager. And then we'll put 7, all right? That's going to make wages greater than 5 to be true. And this time, we're going to put 50. So that's going to make 50 less than equal to 20 false. So true or false yields true. So what it's going to do is going to calculate it. See what I'm saying? So I put the same information, but what? I use a different symbol, all right? I use the R symbol, and it yields the true, all right? So if we look back at our table, so that's the and, but look at the R, okay? Look at R. R says, let me scroll it over because you can't see the P. R says, if P is true or Q is true, it will yield true. And it also says if P is true or Q is false, it'll still yield true. Or P is false, well, P is false or Q is false, it'll yield true. But if both are false, the P is false or Q is false, it'll yield false. All right. So you got to keep that in mind. Now, the thing is, you can build on this. All right. So what happens is, in here, I can do something like this and do something, and I could do something like hours greater than, less than equal to 20. I'll do like that. It don't matter. Greater than or equal to, greater than or equal to 10. So what happens is, all of a sudden now, I'm asking if hours is less than 20 and then are greater. But you got to understand, I don't have any grouping. So it's going to do this and this, get a result, then do this and this and get a result. So say we take the 7 and the 50. Okay, 7 is greater than 5, true. Okay, then it's going to take 50 less than equal to less than or equal to 20, that's false. Okay, so true or false yields what? True, right, class? So true or false yields true. Then it's gonna say if hours greater than or equal to 10, that's true. So true and true yields true. So what'll happen is all of a sudden now it'll give you that positive because I asked this question, then this question. All right, so let's run it. And it should give me the results. Let's see. What is that? So I'll put John, and I'll put 7, and I'll put 50. All right, so see what happens? It didn't do this and this. So because this or this yield to be what? Well, this, yeah, wait. Excuse me. 7 is greater than 5. That was true. Is where is that? Wages, what we put 50. 50 less than that, that's false. But true or false yield to be what? True. And then is hours greater than equal to 10. That's true. So whatever this equated to be true, true and true yields true. So it did it, right? Now watch this. If I take this, you know what that? Yeah, and I'll put this here. I'll put this here. Now I'm asking it in a different order. All right. So what? And I'm gonna do 7 and 50. Is 7 greater than 5? That's true. Or 50 greater than or equal to 10? That is true. That's gonna be true. Okay, so that'll yield that to be true. But and hours less than equal to 20, 50 less, that's false. So true and false yields false. So I should get zeros for gross pay, whatever. Just by me switching it around and asking it in a different order. All right, so we'll run it. John Doe. 7 and 50, if I could type. And 50. Still give it to me. Why? This and this. Okay. Oh, because they're going to give true. But then 50 is not less than or equal to this. Why they give it that? Wages is 7. That's true. Hours greater than or equal to 10. That's true. True or false, that yields true. Then and hours less than or equal to 20. That's false. So it should have given me this false. It should have did false on this one. It should have printed what? 0. It should have came here and did the else because it was false. True. Because and mean both sides has to be true. 50, and I'll put hours in. Yep. Ours is 50. So this created this yield of false. Why did it print it? This is true. This is true. True. And true or true is true. Right. And false. That should be, wait. And true and false. I don't know why I didn't do that. I don't know what happened. I'm gonna have to look at that. Because this is 50. 50 is less than equal to, nope, it's not. And that's and. Wow, I'm gonna have to look at that one. That's right. Hours. And hours less than equal to 20. No, that shouldn't have print. Wages greater than. That's right. Because but it should do it. It shouldn't do it. I shouldn't have to do this. Not just gonna group it, but it still should work because they're gonna go should go from left to right. It should go from left to right. Okay, this should be here. But it still should go from left to right. Debug, and that's gonna be false. But still. Let me look at this. 750. So it did it that way. But why wouldn't it do it the other way? Because it's still because it's gonna do this and then get a result, and then it's gonna do this and get a result. And it's doing it the same way. It should do from left to right. I'm gonna have to check on that one, class. I'll get back with you on that one. But it should have gave me the same result because it just is doing this. It should do this first and then do this second. All right. But the first one worked where it did this and this, and then it did the last one. So I'm not sure. And like I said, I might be looking at the logic wrong, but I'm looking at it as this is true. This is true. True or true is true. And true and false is false. You know, yeah. We'll look at it though. I'll look at it. But that's how you can build on with your ands and your r's. All right. So if you look here, temperature less than or equal to 20, less than 20, and minutes greater than 12. So this excluding 20, all right, and this one is excluding 12. You know, anything above 12. So you got to kind of understand your math operators. Okay, greater than or equal to, less than equal to, greater than, less than, not equal to. All right. So in telling you this, you know, you must provide a complete expression, that which I was telling you. You can't do temperature greater than 0 and less than 100. You got to have this comparing something on this side. Temperature greater than equal to 0 and temperature less than equal to 100. That's understandable. So look here, and this is what we saw on this other page. True and false yield false. False and true still yields false. And obviously false and false yield false, but true and true yields true. So I'm not understanding why the other one did what it did. All right. So if you look, let's look at what they have here. They have what? If employed equals Y and recently grad equals Y. So what they did, they combined it. They asked the user to input whether or not they was employed with a response of Y or N. Okay, they asked them if there was a recent grad with a reply of Y or N. So if employed is equal to Y and recent grad is equal to Y, then you fall into the true condition, right? Further down, you're gonna see how the program kind of changes because of how the logic is. They nested it. They asked if this, because see, when you ask if both of these are Y in the same if, now your response gonna be, you know, just concrete. Oh, you qualify. But if you ask them separately, if let's say, if employed equal Y, if it's not, you could go and give them a response. Oh, you are not employed. Okay. And then you don't have to go and check to see if it's grad. Well, you know, or if employed, you're right. And then again, if this is Y and this is N, you know, you're gonna get this, and it's a double message. But if you do it where you break it down, this could be Y, this could be N, and this is N, then you could say, oh, you're not a recent grad. But if you ask them together, you're gonna have to give pretty much the response in a combined way. All right. So, cause look, if any one of these is no, you must be employed and have graduated from college, but you don't know which one made it false. So, you know what I'm saying? You don't know whether or not there was grad or whether it's whether it's employment or their graduation. So the R operator, we looked at that. The R operator is the two pipe symbols, and then you can do the same if temperature less than 20 or temperature greater than 100. Now what you just did, you excluded what? Everything in the middle. So if temperature was 20 through 100, it would go to the false condition, all right? So you excluded the range in between that, 20 and 100, all right? So that's how the R works. Okay, and still, you must still have a complete expression. Temperature less than 0, or not this one, but this one, temperature greater than 100. This will give an error, always. And this is pretty much like the table we saw with P and Q. True and true or true is true, or true or false is true. False or true is true. False or false is false, and false or true or true is true. All right. So, okay. Now, and it says all it takes for our expression to be true is for at least one side to be true, and it's automatically true. All right. So that's all it's saying. Now, so let's look at this same thing again. So now what they did, they asked if what? Well, this one dealing with income. All right. So what is your annual income? They asked them what the annual income. All right. How many years did you work on the job? So that the user is inputting the income and the number of years that they worked on that job. But then they asked if income is greater than or equal to minimum income, which was something you said. They said in the for the constant variables, 30,000, 35,000 for the income and 5 for the year. So it asks if income is greater than or equal to min income, which is the 35,000, or years greater than 5. So years can't be 5, years have to be greater than 5. So if they're making 35,000 or more, and they've been there 5 or more years, then they're gonna see how you qualify. Okay. But if not, if any one of these is false, no, not anyone. Because it's like the only way of both of them be false, then it'll tell you you must earn at least whatever or have been employed or whatever. So if both of them are false, then it'll fall in this false condition. Because we use what? Or, right? Because we use or, both sides, only one side needs to be true, right? But if both sides are false, then that's the only way it's gonna fall in here. So that's how you gotta look at your and your or. And look here, they put in 40,000, so that made income true. They put in 2 for job, that made it false. Wait, no, but because it was an R, the 40,000 made it true, right? So here they put in 20,000 for the income, which would make that side false. But then they put 7, which make that side true. So you got R, so that you qualify. But then you got 30,000, which make that side, the left side, one side false. And then you got 3, which make the other side false. False or false. You must earn at least whatever or have been employed more than 5 years. Okay? So that's how the or works. And like I said, with the not, we used the not already when I said not whatever with that variable. So what this does, this takes temperature greater than 100 and reverse it. All right? Because if we didn't have the not here, we'd say, okay, if temperature greater than 100, do the true condition. But that not says if temperature greater than 100, okay, take it and do the false, all right? It's like temperature not greater than 100, all right? Temperature below max, all right? So it's like you kind of reversing what you're asking, all right? Temperature greater than 100 without the not, it just worked that way. When you put the not, you're reversing it, okay? So it says the not operator performs a logical not operation. All right. It takes the operand and reverses its truth, all right, or falsehood. In other words, if the expression is true, the one operator returns false. Simple as that. All right. So if I put a temperature of 120, but I got not, it'll turn it to be false. Temperature greater than 100, we looking at it as being true, but we got the not, so it returned false. All right. So that's how it will work. So and if the expression is false, it reverse that and make it true. All right. So and it give you this example. All right. So look here. We know true is 1, but not true is 0. All right, or false. We know false is 0. All right, but true, but not false is true or 1. Okay, so that's the only thing. And sometimes you may need to do that for whatever reasons or whatnot. So let's look at this annual income again, while you're doing the income in the job. You're inputting the income, you're inputting the work experience or the number of years. All right. It asks the same question again. If income is greater than, well, if income is greater than equal to min income, or years greater than a min years, we're doing this. Else you qualify. But what I didn't read what? The not. So the not reverses everything. And now what? Rather than say you qualify, the not says, okay, this is gonna be the false condition. So I have to put my what? My prompt saying that you don't qualify because of whatever reason, because that's what it's gonna do, because I said not this, right? And then the default to that is you qualify. All right. Okay. All right. So now, oh, that's what this is where. What's that, Miss Dory? Yeah.
Oh, all right.
All right, I'll call you.
All right, bye.
Okay. So now, so when we did that previous expression on the in the program, this is what I was missing. All right. Look at this. It's a logical operators and order of precedence. So what is showing? The not has precedence over both and or. Everybody see that? But then and has precedence over or. So if we go back to our program, which I didn't actually do when we did the program. Oh, okay. Let me take that. I'm gonna take this back off. Okay, take this off. Take this off. Take this off. Take this off. So what it's saying is not has precedence over and or. And has precedence over or. So what happens? It had to do this, okay? Well, still it would be right. It had to do this first because of what? The and. Hours greater than or equal to 10. When we put 50, that was true. And hours less than equal to 20, where hours was 50, that made it false. So true and false yields false. But now, once we doing our precedence, once we satisfy this, now we go and try to satisfy this. Wages greater than 5. 7 was what we put in. 7 is greater than 5. That yields true. And what? True or false yields true. So that was the issue. Okay, I didn't take in consideration the precedence of and over or, which means I'll do my and before I do my or. Everybody understand it? And that's why we got the output that we got, because it did yield true. in the final analysis. Questions? All right. So now, and it tells us about the operator not. We know it has a higher precedence. So before it does anything, going here, it'll just reverse whatever. And most time what people do, they'll solve it, but then they'll say, oh, let's reverse it. But it has a higher precedence. All right. So that's all. So now look at this. This says this is not equal to this. Why? Because this is grouped. This is X greater than 2. So if X was 3, this would yield false. Because 3 is greater than 2, which would be true, but then this would make it false. Now this is different. This would say, okay, not X greater than 2. So X, not X, if X was 3, X would be true, which would yield 0, because what? It was 3, take 3, which was yield 1, which the not yielded to be 0. 0 is not greater than 2. So you see how you would get a different result based upon how you group this stuff, all right? So if you group this expression, this would yield 0, all right, if X was 3. If X was 3, this would yield 0, all right? Or still yield, it would yield 1, because this 3, no, it was 0 greater than 2, this would yield 0, 1. Because 0 is not greater than 2, but not, no, it just says 0 greater than 2. But this would be like 3 greater than 2. It is, but then not. This would be solve for X, not X. Okay, X is 3. Okay, that's 1, but then 1 turned to 0. 0 greater than 2. All right. So this would be 3 greater than 2. This would be 0. So that's why the difference comes in. All right. And this explained it in here. The first one expression is like X greater than 2. This one asking if the existence of X greater than 2. All right. So it's a big difference. Big difference. Now, looking at this grouping, this is the same. This and this, because what? P and Q. All right. Same as this. So you put the 1 parentheses around everything. You can do this, but you have to group everything when you do your if logic. All right. What else? All right. Remember, you have to use the what? The double equals to do a comparison. If you just do the equal, you're assigning. So and like I say, I ran into that issue at the beginning when we did the program. You got to be mindful of that. All right, got to be mindful. All right. Checking the numeric range, same thing, but look, what would this do? X greater than or equal to 20 and X less than or equal to 40. What is it doing? What values are valid for this? What numbers are valid? 20 through 40. Anything from 20 to 40, right? Look at this one. If X is less than 20 or X greater than 40, which values are valid in this one? Anything 19 going down or anything 40, above 40. You got what I'm saying? So you're excluding the middle part of it, all right, with that or, all right? So like I say, you can read through this, that it helps you to do and or with number ranges, but you can do that with anything. If name is equal to whatever and age is greater than whatever, or birth month is equal to whatever. So you could write any kind of expression that you want, given using and or and grouping it and whatnot. All right. So, and again, they're just showing you that truth table all over again with and or. All right. And we know not just turns true false and it turns false true. Okay. All right. Now it talks about menus. Now using nested, it's okay to use nested ifs with a menu, but most time with menus they use you can use a while. Well, that's loops. We never gotten to loops, but you can use case statements. All right, you use the case statement. All right, so it tells us what did it skip to? What did it skip to? Yeah, okay. You can use nested if else statements or the if else statement, if else if statement to create a menu-driven program. A menu-driven program allows the user to determine a course of action by selecting from a list of actions. So what happens is you might have a menu, might say main menu. Okay, one might have option one, and it might says, okay, input student names. 2, input or whatever record. 3, do whatever. So you can be directed to execute either modules of the program or whatnot. All right. So and normally in computer science, normally you have add, update, or remove, or which is delete, change, which is update, print, or print a report, or quit. All right. Those are some of the simple tasks of managing data. All right. So, and this could be an example where you have 1 add, 2 removes, 3 change, 4 print, 5 quit. So what you would do, you'd have this listed, this menu listed with the see out statements, and then you'd have a prompt, please enter choice, or what would you like to do, or whatever your prompt would be. And then you do the CN, and then you'll read in the numbers as numbers or characters. I would say read them as characters. I think it'll be better for you as characters. So, because numbers can be characters. All right. So the user selects one of the operations by entering its number. Okay. If you enter 4, for example, it causes the mailing list to be printed. All right. So that's just an example of what it's telling you how you can do this. So look, if choice equals adult choice, and adult choice was given the value 1, child choice a value 2, senior choice a value 3, and quit a value of 4. So if it acts in if choice, like when you input a choice, what do you want to do? If you put in 1, okay, if it's equal to adult choice, then it's going to do some things. Okay, ask you how many months, it's going to multiply your charge, get your charges, multiply that times the adult rate, and then it's going to print the rate out. All right. If it's 2, you do this. If it's 3, you do this. And if it's 4, you quit. All right. So that's all they're telling you. You can use your if, else, if statements. All right. And in this example, it's display the menu. They inputted 3. Senior citizen, multiply the number of months, well, got the months, multiply the number of months times the senior citizen rate, and that's your results. All right. So that's basically what it's saying. Now, focusing on software engineering. Now, class, many times when you write code, even when you write, I know when you write my code, you just say, oh, let me go in and try to run it, try to write it and get it done. That's good, but at the same time, eventually you're going to be given larger and more complex projects. So I would tell you to get in the habit of documenting, get in the habit of planning out your program before you actually get into it, because that's a part of the process of writing your code and trying to write it as best as you can, as soon as you can. Because if you get on the computer, type, okay, I'm gonna start over. Oh, type, oh, I'm gonna start over. Oh, type, I'm gonna start over. Oh, well, just scratch it, let me go back, start over. If you took your time, planned it out, write it out, went through the motions, checked it out, see whatever. Okay, I need this here, whatever. Then when you sit down to write it, you pretty much have everything in order, and you putting it in, and you're gonna have less numbers of retries than you would if you just go sit down and try to write it. And then sometimes you get bogged down, like, oh, well, I'm overwhelmed, whatever. Don't have no kind of reference because you just started adding. Okay, got that working, adding, got that working, adding, got that working, adding. oh, now the whole program bombed up. What am I gonna do? Nothing written down, nothing, no kind of logical steps, no kind of documentation. So it's like, man, I might as well just start over. So you want to get into that practice, good practice of planning your program out, variables you're going to be using, how you plan to use these variables, how the input going to be, how the output going to be, all that stuff, and you got it down. You can reference it back to it. You can talk with somebody and you know your program. You know it in and out, inside out, and you can actually, even if you have to, you can present it. Because some people can write code, and the next day they don't forgot why they did what they did to make something work, and they got to go back and try to look through it to figure out what they did. Because there's no documentation, they know whatever, they just trying to get the program to work. But like I say, I would say do that. A lot of people don't do it until they have to, but I would say try to do that. Know it's time, but validate input. Most programmers with C++, they'll write code and input character data, right? They input character data and use some of the functions or whatnot to validate or convert. Because you can read in a number as character, and then you can do the typecast, or you can do a character to what it is, character to int, or int to float, or whatever, to change something to a different data type. All right. But validating your data. Now, we don't really stress it a lot, but look at this program. If you were writing a program to where I told you to input test scores, now we don't tell you by right, and I would say make sure you validate your input. Okay, so, and even it could be names. Okay, that names don't have what? Numbers in them. But like I said, that would be a little too advanced now for this class. But you can check the characters in the name to see if it's alphanumeric, if it's all characters, or whatnot. If you're putting in test scores, and you say, well, what are the max scores on a test? 100. Okay, what's the minimum score? A 0. So now what? You should be able to, if somebody put in a test score, anything other than 0 through 100, you should tell them, oh, invalid test score, please enter test score again. You understand? That's validating your data. And what? And especially when you're sending data to store in a data bank, you don't want somebody to give you all kind of bad data. Because like what's the famous term of phrase of computer science? Garbage in, garbage out. Whatever you put in there, that's what you're going to get back. So if you input scores and scores are from 0 to 100, you should try to force the end user to input only valid scores. Now, does that guarantee your data is correct? No, it doesn't. But it guarantees that the data is within the range that you put in your program. And you say, well, what you mean? Well, a person can make 300s. If you put in 3 test scores, they can make 300s on 100 on every test. But the data entry clerk could put 10 for one of the tests, right? 10 is a valid number. So unless the person inputting the data catches that error themselves, a 10 has been put in for 100, right? Which is a valid number, right? So things like that, you can't control, but you can control, the validation of, okay, if I want numbers, I want only number. If I want character, name, I want only a name. Stuff like that you can control as a programmer. All right, anybody have any questions? And like I said, we'll continue with this. Look at this. Okay, string. We talked about it. We don't went over this in this class, right? I think I'm going over this again. I think that's what I did. Let me see something. I think the class. Let me see something. Not my system. Okay. Let me see something, Claire. Oh no, okay. All right, it could have been my other Claire. But no, I think we went over that though. All right. It just seemed like I went over comparing the numbers and whatnot, where I compared each number. Okay, but we didn't do that. All right. So next class period, we'll continue on and we'll look at these expressions. The switch statement, we'll look at that. This switch statement is like an if statement. Notice here what happens. They're asking them to input A, B, or C, all right? So you see in that value. Then switch that value, that variable, whatever that variable name is. Then it say case, if it's A, I want to do this, then break on out. If it's B, I want to do this, break on out. If it's C, I want to do this, break on out. Now, by the default, if it's neither one of these, A, B, or C, that the person entered, then you would output this. And it could be anything, but you did not enter A, B, or C. Now, you're looking at this, you see these breaks here? These breaks are very important. If I put in the letter A, if I took out this break here, all right, for this, just this one, and I put in the letter A and ran the program, put in the letter A, it would print out, it would say, okay, case A, okay, you entered A. If I don't have a break, it'll stay and do the next one. Without checking this, it'll do the next one, you entered B. Then it'll break, okay, break on out. So the breaks are very important to case statements. And notice, rather than me having if choice equal A, do this, if choice equal B, or else if choice equal B, else if choice equal C, I got case this, do this. And I can add as many statements as I want in the list here, and so on and so forth, all right? But sometimes you may want to eliminate a break. And look at, I wanted to see if they had ABC. Yeah, look at this. Look what they did here. If you wanted to count the number of A's in a sentence, and that's if you're going through a loop, but we're not to that point yet, but you read each character, you can do something like this. Case A, lowercase, and then case A, uppercase. But notice you don't have a break, you don't have nothing else. But all you're doing is checking to see if it's an A or a lowercase, and then you're doing whatever, and then you break it. And I could have had A count plus plus, or A count equal A count plus 1. So every time it hit an A, it'll increment. But what? It'll check for a lowercase a, not check for uppercase A, or A is an A, whether it's up or lower, I want to add it. Unless you write the code to check for uppercase A and lowercase, then you would have to break it off, do a break. Okay? All right. So we'll stop here and we'll continue on next class period. Okay. We'll start out with looking at this, the case statement, and let's see what else. Look at this. And okay. All right. So, all right. So let's we won't have class next class period because of spring break, but it will be the following week, which is the what it is, the 5th, not the 5th, the 13th. All right. So we'll meet back on the 13th. All right. Anybody with any questions? Any questions?
No, sir.
All right.
So the programs, our three programs, they do Monday night, right? Professor?
Well, let me see it. Let me look at that. Let me check this out. Cause how's it going? Because I can extend them. Being that we don't have school that week, I could extend them. But if I put the date, I can check them. But I can extend the date, give you a little more time if you want to. You know what I'm saying? Because I know it's the holidays, whatever, and all that.
Yeah, I think I'm gonna need a little more time, Professor.
Okay, so I can make them do by the next class period. All right.
Yes,
All right.
thank you, Professor.
All right. So cause really we off on that week. You know what I'm saying? So I'll do that, and like I say, it's just that I'm gonna have to grade them toward the end of the semester, but I'll get that done. All right. And then, like I said, we'll have our test. Hopefully, after we finish, we get back. I'll finish chapter 4. We have our test, and we start on chapter 5. All right.
All right. Thank you.
All right. Y'all have a good one, man. Happy Easter. Stay safe. And
You too, Professor. Happy Easter. Have a good
All
one.
right.
Yeah, have a good one.
All right. Have a good one.
Thank you again, Professor. Have a good
All
one.
right. Hey, have a good one, man. And I'm going to think on that. All right.
Yes, sir. Appreciate a lot. Bye bye.
All right.